So let's see, add this to our list of things. A to the m divided by a to the n is a to the m minus n. So there we go. Okay. So let's see here. We had already said that a to the 0 is 1, right? Okay. And so, since we've already said that, let's see. If I say a to the 0 divided by a to the 3, that would be what? A to the negative 3. Okay. And that's, of course, by this, which we've proven from that, right? Okay. And so, let's see. Well, this we know is 1. And so this is 1 divided by a to the 3rd, which is 1 divided by a to the 3rd, right? Which is a to the negative 3. And what do you see progressing there? I've got an idea now for a definition of what? Negative exponents. Right, okay, but you're also right when you said division, because if you take a look at it, positive exponent is repeated multiplication, but negative exponent would be repeated division. Okay, and so I can say a to the minus n is what? 1 over a to the nth power, right? So a to the minus n is 1 over a to the n. That's 1, 2, 3, 4, 5 of those rules. Okay. What do you think so far? Is this better than just being told what the rules are? Okay. Have any of you seen the rules explained this way before? A few of you have? Okay, then you've got have had good teachers. I'm glad to hear that. No, these rules, okay, all the rules are made up essentially from the definition, aren't they? Okay, they're very consistent. So now let's see what else we have got here. Oh, just as another little thing, suppose I did a to the 3rd divided by a to the 3rd. What would that be? A to the 0. But then again, you also know that anything divided by itself is 1. Guess what? There's another proof of a to the 0 being 1. Okay, so, anything divided by itself is 1. So there we have that little idea that also helps us see that. So let's see. Here we go. Suppose I had a times b to the 6th power. Okay. Now what is that saying? Okay, but it's a to the 6, the 6 powers, or 6 factors of a to the a times b, right? Okay, 6 factors of a times b. So a times b times 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 a times b. Okay. Now, that's what it's saying. All right. After all, that's the definition, isn't it? Okay. Now the question is, what property could I use to get all the a's together? Do you remember? Remember. Say it. Commutative property. Very good. Okay. So the commutative property, all right, means I can get all the A's together and all the B's together, because the commutative property for multiplication essentially says it does not matter what order you multiply things in, right? Okay. And so this is going to be A times A times A times A times A times A times B times B times B times B times B times B. Now, what property would allow me to group the A's and group the B's? No, not the distributive property this time. It would be the associative property. Okay. Now think about it, all right? You know, I wrote this out like this, but essentially I had these groupings here, right? Okay. I'm removing the groupings and I am rearranging things, okay? The associative property allows me to regroup things, right? Now the distributive property does deal with grouping of a sort, but not this way. It's multiplying a group of terms, and we'll talk about that, by a value. And so we'll talk about the distributive property a little bit more, particularly when we get into the third section where we deal with polynomials, and the fourth section when we deal with factoring. Okay. So this is A to the 6th times B to the 6th. So let's see here, adding to our little list here, if I talk about A times B to the nth power, that is
A to the n times B to the n.
A to the n times B to the n. Okay. Now, really, anything other than these are just simply refinements. For example, you can see that if I talked about multiplying a fraction by itself several times, you know the process for multiplication of fractions, don't you? What's the process for multiplication of fractions? No.
On the topic.
Talk about
No, that's
that.
division.
And we're going to have to talk about that. I hate that same change flip. We're talking about division. What's the process for multiplication of fractions? You multiply the numerators and you multiply the denominators, right? Okay. And so here we go. We have A to the n over B to the n. Why? Because, you know, I'd be multiplying all these out. You know, if I were to do this, A over B, say to the 4th, would be A over B times A over B times A over B times A over B. And can you see that here in the numerator I'd have A to the 4th, and in the denominator I would have B to the 4th, right? Okay. And so you can see this rule is ultimately very reasonable. Okay. What else might they have in there? Let's see what they've got. As I said, everything else is just a refinement. They've done this as along with that as a refinement on page 20. But we'll just stop there. However, because it is one of those things which people have difficulty with, I am going to talk about the definition of division just a little more. Okay. By the way, did this help with properties of exponents? Does anyone here feel like they understand it better than what they did before they came into class? Properties of exponents, again, everything follows from the definitions. And we cannot just memorize them. How many of you find there's just too much to memorize? Yeah, there is too much to memorize. I hate memorization. Okay. But as long as I can develop something, then I'm in good shape. Okay. Now we had said the definition of division, this is something you're going to want to know, by the way. This is, every time we come along with a definition, remember it does what it does because it is what it is, okay? And so basically, you need to know those things. Let's just talk for a moment about how you learn. And how many people have ever seen a baby grow up? Watched a baby grow up? Okay, I've had 4 of them, okay? And so let's suppose that I have my daughter Katie, and she is beginning to talk. What sort of things does she say?
Daddy.
Daddy, what else? Mama, what else? Ball. Okay. What is it that she's saying? She's saying the names of things. She is not talking about actions. Even if she says no, to her no is a thing. She doesn't understand, the baby doesn't understand verbs at that level. Okay? It's not like that old Circuit City commercial where, quick, you're going to say your first words, and so get the camcorder, and so Dad gets the camcorder, and the baby looks up at him and says, "Oh, Dada, you paid too much for that camcorder." Yeah, that doesn't happen like that, okay? So actually the very first level of learning is name learning. Name learning essentially tells us what it is. Okay. Now, so I give Katie a ball, and she just stands there holding it saying, ball, right?
Yep.
You haven't lived around babies. What would Katie do with that ball?
She'd throw it.
She'd throw it, toss it, kick it, hit it, sit on it, try to put it in her mouth, right? What is she discovering? What it does. She knows it's a ball, so she knows what it is. By playing with it, she discovers what it does. That's concept learning. Now, Katie plays with balls, with blocks, with other things, and she discovers that the properties of what a ball does are different from what other things do, and she puts those things together, and she realizes there are some common things that govern how a ball works, right? Okay. So she puts together essentially a series of rules. Okay? Rule learning essentially is why it does it. It's not memorizing stuff, it's actually going the next level on, after what it does to understanding the why of things. Okay? And then, of course, what we would all like to be at the very end are problem solvers. And problem solving essentially teaches us how to use it. Now, if you learn anything well, you learn it this way, bottoms up. If you try to mix these things up, then you get into trouble. If you try to memorize the rules without understanding what the things are to begin with, then you're going to be in trouble. If you try to understand what something does before you understand what it is, you're going to be in trouble. If I took my car to a mechanic and the mechanic couldn't even say the names of his tools, I'd get my car out of there right fast. Because if he doesn't know the names of his tools, then I don't really have any guarantee he knows what to do with them, right? Well, I don't have a guarantee on that, okay? But would you be willing to trust your car to somebody who thinks of an air wrench as a thing gummy? I mean, so believe me, having had experiences with